Hello back. On our previous video, we reviewed the theory of our supply chain tutorial, and now we're gonna go into our virtual machine box or Ubuntu uh, machine, and now we're gonna follow the steps that we have in the presentation, and we're gonna actually go and do the tutorial. So let's start. The first step is open the Sawtooth instance, and what I'm doing here is I'm going into the folder that where we have all the code. I'm now gonna open a terminal. So on that terminal, I'm gonna run the docker compose command, and what I'm doing by running that is I'm starting an instance of Sawtooth. The password that I just typed is Cascon2018. You can have the password and the command on the slides. So what is going on here is we have an instance of Sawtooth. That means that we have a blockchain running in our machine. So let's go in and see the web interface of this instance, right? Because the command line is a bit difficult to follow. So let's open a Firefox, and then let's go to localhost port 8000, and you're gonna see a Sawtooth web interface. So here you will see some options to create a holder, create a tuna, send it, and then some information about the current tuna and the current holder. Okay, our first step is going to create a couple of peers. So go to the select holder and then click create new pair. That's one user, and then let's have another one. Okay, so for now we only need two peers, and we're gonna play with them. We're gonna create a tuna, and then we're gonna transfer to another peer. Okay, now our next step is to open a second terminal. Yes, on this terminal, what we're gonna do is we're gonna log in into our container on Docker. So I'm gonna run this command right here, the Docker, and what we're doing is we're opening a shell bash into this container, into this Sawtooth container. Again, the password is 2000 Cascon 2018, and now we have a terminal into the Sawtooth container on Docker. So let's put that on the side for now. And now what we're gonna do is we're gonna create our first asset. So select the first user that we create, and let's create an asset called Nemo. If you saw, and that's part of our next step, step 5, I'm gonna click create, and I want you to keep an eye on this size, on this terminal. So let's go ahead and create the transaction. Now what happened? We have a new record, a Nemo, and a holder. This holder is the public ID of our user and the name of our asset, which is Nemo. But if you go and look into the log, you will see a bunch of information about the blog, about the components that we talked in our previous video. This is the REST API, getting transaction, this is the validator, and I want you to try to find a transaction which is create Nemo. And let me try if I can do that right now. Yeah, this log has a lot of information and sometimes it's quite hard to follow, but we have the handler here. So if you look at this log, the same transaction that we did in our web interface is on our in our log. Okay, so our next step is going to be to send that new asset to our second peer. Okay, going back to the web browser, we have the Nemo, we have the holder. So this user has multiple, or has a Nemo, has a tuna, right? What we're gonna do here is we're gonna transfer the asset to your second peer. So let's select the second peer on this drop down and let's click transfer. Did you saw how this log changed? So that means that the transaction was logged into the chain, but something interesting is that the holder is the same. The holder did not change, and that's because for a transaction to be valid or for a transaction to be complete, all the holders must accept the transaction. So this is the concept of that the chain is immutable. So I want you to go to the second terminal that we open, and now we're gonna go and look into that immutable transaction that I'm talking about. So I want you to run the following command, and here you can see the blocks that we have in our blockchain. You can see this step as looking at the database. So I have two commands that I want you to see or to test. One is the block and one is the transaction. So I want you to see something here. The first block gives us a list of blocks, and if you remember the previous video where we talk about the blocks, so each block can have transactions or one or two transactions, and these are the family processors that we were talking before. This is the processor, the transfer processor, the Sawtooth setting processor. This is the idea for transaction, and this is the payload. Now there is a command to see a specific transaction, and I want you to figure out or to think about how can we see this transaction. We have something, a command that is called transaction show. So using that command and this ID, how can we see a transaction, and how can we review the header and all the information that is part of the transaction? So go ahead and try to see or try to show the first transaction that we have here. And if you're looking at the numbers and you see something different, it's because your computer is going to generate different key pairs. So the public key and the private key is going to be different for everyone. But you should see something similar with this, but with different numbers and letters. While you do that, I want you to go back to this log and also try to map between the REST API and then this log about the validator, which is building on top of something and then finishing the validation of this specific block. So the block ID that you have here should match the block ID you have on the second terminal. And if you're still working on that, I will show you the command right now, which is transaction show and then the ID. And then here we have the transaction header, all the information, and here is our payload. If you see the payload is quite hard to see, then that's because it's encoded in a base64. But I want to show you a simple way to decode that using the terminal, which is do an echo and then the payload, pipe it with this symbol, and then base64 hyphen decode. And here we can see our payload. The payload is a transfer action, the asset is Nemo, and the owner is the new owner. So if you see, this is something different at maybe you were expecting that this owner to this owner. It just means that this asset has a new owner. Okay, now let's go back to our web browser and let's log in or simulate the login to your second peer. So go back to select holder, select the second peer, and you will see a new set of options, which is accept and reject. And this is what I was talking before, that the ledger is an immutable ledger, and if you want to send something, the other person needs to accept that something. So both peers have to agree on the transaction. If you see the holder here, the holder is the previous owner, but as soon as you accept it, now we don't have the option anymore to accept the transaction because we already accepted, and now the owner changed. This is our new holder for Nemo. And if you go back to your second terminal and you run one of the commands before, you will see that you have a new transaction here with the correct owner. Okay, for the demo, that's all I wanted to show you. This is how you can have an instance of Sawtooth, a simple, really easy instance of Sawtooth using Docker. Then you have a web interface where you can still playing around with creating a second Nemo, and then you will see the list. So I want to encourage you to go and try to play around a little bit more about with this setup, and then try to play around also with this blockchain interface, command line interface, where you can see the bash and you can also see a lot of different stuff here. For example, you can see the batch, and each command is going to give you a different information and different attributes. For example, here we can see who signed that batch, and if you remember, a batch is just an abstraction or encapsulation of multiple transactions. That's all that I have on this supply chain tutorial. If you have any question, please feel free to email me. And that's all. Thanks for your time and enjoy the rest of your conference. Thank you.